Today we're going to be working on 8.3 transformations of quadratic functions. This is a nice lesson that just helps you to understand the basic rules of looking at a quadratic and how it has been moved around a coordinate plane without having to do too much work. It's just these are how these move, how they behave. And you can always check them on your graphing calculator to make sure that you have understood the rules correctly. As always, let's start by putting your name at the top of your paper to make sure what's yours stays yours and nobody else gets a hold of it in case you lose it. All right, so our notes remind us that the vertical translation is going to slide up or slide down. So we'll make a note there. Or shift up and down. It's not a reflection, it's just a slide. All right, so that vertical translation happens at the end of your quadratic equation. It's going to be a constant number that has been either added or subtracted to your equation. If it is added, if it's a positive number, then it's going to slide up, plus d. If it is a negative number, if it has been subtracted, this is going to slide down, minus d. So a quick reference might be to say, oh, all right, if that's my original quadrant, my coordinate plane, my plus d would look like that. And if this is my original coordinate plane, my minus d would look like that. And that's just a good hint, a good reminder of what it is you're going to be trying to draw. So they're still centered here about the y-axis. Their vertex is still on the y-axis. The axis of symmetry is the y-axis. It's just been pushed up or pushed down with a vertical translation. Let's look at our first example, example number 1. Here we have two functions. We're going to graph them both. And we are always going to start with our f of x. It is our parent function. And we know that the parent function always has a behavior of -2, -1, 0, 1, 2, with -2 squared, -2 times -2, +4. -1 squared, -1 times -1, +1. 0 squared, 0. 1 squared, 1. 2 squared is 4. I got all of these numbers by plugging the x values into my original function for x. So let's go plot those points. That parent function will be the same for each and every one of these functions. So -2, +4. -1, +1. 0, 0. +1, +1. +2, +4. There are the 5 coordinate points of the parent function that we can draw every time. And it's really important to do that to help your brain understand as a reference how our secondary equation has changed from the first one. So this is a -4, which means we're going to slide down 4 units. So let's write ourselves a note. So shift down 4 units. To plot this, you can literally take each of the coordinate points that we plotted in the beginning and just count down 4 units and plot them. So 1, 2, 3, 4. Here's my first coordinate point, negative 2, 0. Let's go to our second. 1, 2, 3, 4. Negative 1, negative 3. Third coordinate point, 1, 2, 3, 4. 0, negative 4. My fourth coordinate point, 1, 2, 3, 4. Positive 1, negative 3. And my fifth coordinate point, 1, 2, 3, 4. Positive 2, 0. Alrighty. So here we have our new translated g of x on our coordinate plane. So let's label these. This is g of x. And this is my f of x, the original. All right, stop the video, and I want you to try to do the second function, set of functions right next to it. It follows very much like what we just did. And if you get stuck or you want me to check it, come and let me know. Here on problem number 3, it is very similar to the one that we did a moment ago. A slightly different vocabulary, slightly different setup, but not too different. So let's see what is the same and what's different. We have g of x equals f of x plus d, where d equals 6. So this is assuming that we remember that f of x is going to be our parent function of x squared. Oh, well, now that we remember that, let's go back and use the table that we created from problem number 1 right here to plot these points again and just help us to see it on the graph. You don't even have to rewrite the points as a table. You can if you want to, and it might help you think a little clearer, but we don't have to. Let's go plot those points. It is very helpful to use a couple of different colors for these lessons. You'll notice I use lots of different colors. The purpose will just help you to see that a specific color keeps all of one graph and one line of thought together. And when you change colors, that's for a new graph and a new line of thought. All right, there's my original f of x, and it's my parent function. I use the information I know from problem 1. So now let's go look at g of x. G of x is f of x plus d. Well, I know that d is equal to a positive 6. That means that g of x is equal to x squared plus 6. I put that 6 exactly where the d was. That's all I did, was I filled in the blank. So we remember from our discussion in problem 1 that since this d is outside of our parentheses, that's a hint from yesterday's lesson, that this is a vertical shift. And since it's positive 6, we're going to go up 6 units. So let's write ourselves a note. All right, so this one we can do again by just counting up 6 units. And you might say, oh no, I'm going to run out of graph really quickly. Say, yeah, that happens, it's okay. So you can extend your graph. One of the things that's going to be expected of you with the state tests is they want to see if you can think outside of the bounds that they gave you by showing, can you extend a graph and then use it? They might not give you everything that you need to work on a problem. They want to see if you can adjust and roll forward. So here we are adjusting and rolling forward by extending our graph. So now that I've done that, let's see if we have enough graph to count up 6 units, and we'll plot what we can. So if I start on the left, 1, 2, 3, 4, 5, 6. If I wanted to extend my graph even further, I could. Second point, 1, 2, 3, 4, 5, 6. Third point, 1, 2, 3, 4, 5, 6. Fourth point, 1, 2, 3, 4, 5, 6. And our fifth and final point, 1, 2, 3, 4, 5, 6. Yep, your paper's pretty crowded up there, and that's okay. You're working, you're thinking, you're making connections, and that's what's so important. And now we see what our g of x looks like. So let's label that. Labeling it where it's a little less crowded. All right, please stop the video, and I want you to attempt problem number 4 right beside it. And when you've completed it, or if you're stuck, come and let me know, and I will help you out. Very good. In our next section, we're going to be discussing a horizontal translation. In yesterday's notes, we discussed how things that change or show up inside the parentheses go opposite the direction of the sign. This is usually referred to as H instead of C, but that's all right. We can roll with slight adjustments in variables. So we can even make a note of this is frequently known as H. But we're going to slide, we're going to slide left or right. So if it is plus C, we're going to go to the left. If it is minus C, we are going to go to the right. And again, just like we saw before, if you can count the number of spaces, that's exactly what we're going to do here. It should be very user-friendly for you. I hope you're starting to see a pattern of behavior. So we again have our parent function, and we can still plot those points. If it'll help you, we'll redraw the table very quickly since the original table was on a previous page, x and y. You don't have to memorize this table, but it would be very helpful if you used it enough times so that it became something that you just remembered. So often, memorization just needs to be repetition of use instead of a stressful flashcard type moment. All right, let's plot your parent function. Left 2 up 4, left 1 up 1, left nothing up nothing, dead center. Right 1 up 1, right 2 up 4. And there's f of x. It is nicely labeled. All right, our g of x, we have a horizontal shift. Inside of our parentheses, we see a minus 3. So that tells us from our instructions in the notes, we're going opposite the direction of the sign. And whenever we have a minus C or a minus H, we're going to slide to the right that many units. So let's make ourselves a note. We discuss this as being an opposite type behavior because we like to think of negatives or minus on the left side of a graph, and this is going to the right side of the graph. So let's take each of our coordinate points and let's just count 3 units to the right and make new points. 1, 2, 3. So I now am at the point 1, 4. My second point, 1, 2, 3. I'm at the point 2, 1. My third point, 1, 2, 3. I'm now at 3, 0. My fourth point, 1, 2, 3, is at the point 4, 1. And my last point, 1, 2, 3, is at the point 5, 4. Let's connect our points. And we have g of x. Very nice. So it shifted 3 units to the right. Excellent. So why don't you pause the video and try to do 1, 2, 3, 4, 5, 6. I didn't number this problem. This was problem 5. Do number 6 right beside it, and when you come up with an answer, or if you're stuck, come and ask me. Let's discuss number 7. Wrong color. Number 7, we again start with f of x equals x squared. We know those points by now. Let's go ahead and plot these. And here again we have a slightly different vocabulary, and they're telling us that we've got f of x minus c, where c equals 4. So we're going to take this 4 and literally plug it in, insert it where the c is. So our g of x function is now the quantity of x minus 4 squared. That's our function. So since this is minus 4, we're going to shift to the right 4 units. We're going the opposite the direction of the sign. All right, let's do that. Here we are, point 1. 1, 2, 3, 4. Hey, it landed on one of our original points of f of x. I don't think any of the others will do that. Here's our second point. Let's count to the right. 1, 2, 3, 4. My third point. 1, 2, 3, 4. My fifth point. 1, no, that's my fourth point. Fourth point. 1, 2, 3, 4. And again, just like we saw on the previous page, we need to extend our graph just 1 row so that we can see where the rest of our parabola would land. If I start here on my fifth point and count to the right, 1, 2, 3, 4 units. Connect our 5 points. We now have g of x. Excellent. All right, why don't you do number 8 right beside this? Stop the video and let me know how you're doing.